welcome, or welcome back to episode 13 of Whether or Not. I'm Stella Q, and here we go again. In the aftermath of yet another major weather event, we bring the meteorological forensic report to the table. We've all seen the tragedy, well actually tragedies, that have and are still taking place in Spain since late October. Megastorms, torrential flooding, loss of life and property. And sadly, it's going to take years to recover from this. That is if they are given the opportunity, for even during the production time this episode has taken, Spain has been hit again and again. And now there's reports of a flooded Sicily, Italy, and so much of Europe has been hit this year, and Africa, and India, and Australia. It goes on. The list is long. The force of weather knows no borders, nor is it capable of mercy. Is it any different, though? The truth is, that river up there in the sky, it's a powerful entity, one that is often grossly underestimated and largely misunderstood. It certainly does appear that there are more extreme events happening globally, and more often. But I do wonder sometimes how much of it is perhaps the increase of extreme devastation due to neglectful, imbecilic planning of the inevitable urban sprawl. Based, of course, on the development dollar, which is great for a select few, who generally never reside where they make their dinero. But is it really that complicated? Communities who reside at the foot of mountainous terrain surely must know that the picturesque view comes with recherche risk. Any child building sandcastles or playing in the mud with buckets of water knows what happens there. It's beautiful one day, deadly the next. Consistently in the unfolding of the aftermath of these tragedies, the usual rash rumours run awry. This is a perpetual given because this is human nature. But the repeated surrendering of one's unquestionable trust to complete strangers on the internet who are telling you how it is and where to send your money to make you feel like you've done something, because emotion takes over. We probably should have learned by now. There are undoubtedly legitimate boots-on-ground reports and genuine pleas for help. But sadly, within that jungle of desperation and despair, predators lurk. And they know exactly when to stalk, because emotions run high, and this is inevitable. They know it. It is far easier to obscure truth than it is to control it. Some of these folks sure as heck seem legitimate, but then so do actors, when you're mesmerised by their immaculate role play that delivers lines while the cameras are on. In this case, one of those rumours of war, TM, is the removal of dams in Spain and Europe in general. I did spend some hours looking at this, and as per usual, once one starts to look at historical records, etc., and the facts, the thinking is invited to shift from a speculative guesswork to a more informed balance of weight. So please be sure to check out the show notes we put together for you to peruse, as you please, in the comfort of your home, and please pray for those who have lost theirs. So let's put the spotlight on Spain. Was it weather or not?
A todos nuestros hermanos y hermanas en España que están luchando por sobrevivir, mucha fuerza. Están en nuestros corazones y oraciones.
Hello, Jeff. How are you?
Stella, hello. I'm fine. Yourself?
Very good, thank you. It's getting a little bit warm here in the southern hemisphere, but not going to complain. It's actually quite nice. We've had some lovely thunderstorms. It's like the old days, the old-fashioned weather.
What changed?
The newspapers. The news changed. Anyway, it's all very lovely here. We're going to talk about a place that's not so lovely at the moment.
Spain.
What are we going to talk about regarding Spain? We're just going to go over the event that has just happened, or events actually, isn't it?
The flooding at the end of the month, and that has continued repeatedly, by the way. It has had new areas of flooding, so those poor people over there, there's some devastation like Asheville.
Yeah, similar. So what are we going to be looking at specifically today, Jeff?
Specifically, we're going to go big view from the satellite, of course, local view of of the cities and the path of destruction.
Present.
So this is I'm going to go over a bunch of geography pictures here for orientation first of all, plus I'm going to show the satellite picture, plus the radius-on data, and explain why it all happened, and look at flight radar, of course. I have looked at it, but I'm just going to show you snippets of that. And briefly talk about the Tromsø, Norway ISCAT site, but we have a guest, Jim Lee, that is doing a piece on this as well. So he's going to go way deeper than I am. I'm just going to briefly touch on it towards the end.
Mm-hmm.
And
okay. Do you want to just give us a real brief rundown of what an ISCAT is?
ISCAT is the ionospheric heater based in northern Norway. And we want to rule that out as a possibility because a lot of people say HARP, and this is the equivalent of HARP. And
so it's not actually HARP, it's just something that's similar, is it?
It's an ionospheric heater, but it's not officially HARP. It's the newfangled one that is currently being added to right now, but they've got the whole new unit's been brought up and running this year. State of the art, where it's aimable really quickly and stuff. I mean, Jim will have to give more details on that than I'm going to.
Yep,
but my exploration this time was just into when it was on and when it was off. But he gets way deeper. So
okay, all right, good-o.
And we just want to rule that out along with flight radar. And was that low pressure center steered is the question.
Mm-hmm.
This particular screen right here, you're looking at the one that shows Valencia on the right.
Okay, yep.
So that's the city and the area to the south of it where it was affected. And I'm going to read this guy's quote. That red line right there comes through those cities to the south of Valencia, and there's a whole bunch of cities right there. He named them, and Torrent, Alucuas, Cataroja, all these little squares he showed, and I'll share the video with you guys so you can all watch it. And that's where the major flooding was happening. And it started at the base of the mountains. The mountains are to the left side right here. That's the green areas. Mm-hmm. And these two cities, Chiva and Bunol, they got major rains. And I'm going to show you some charts that show the rains that they had. But that started in the mountains and it flowed to the west, or to the east rather. And as all the tributaries came into that, I'll read the quote. Basically, a riverbed that usually is dry. It's meant to channel rainwater to the cities, and it works fine until it doesn't. Mm-hmm. Last Tuesday, October 29th, towns like Chiva and Bunol were hit with insane amounts of rain. That water filled up this gully, turning it into a raging, unstoppable force. By the time it reached the lower towns, it was out of control. So it just kept on getting more and more full. And that area that's highlighted right there was the flooded area south of Valencia.
Right, okay.
So this video will be provided so you get the full context, but I just wanted to show you that's the local area that was hit. Now I'm going to actually jump to the geography part and show you the pictures of the area of Spain that we're talking about. So Valencia is right here on the east coast, and the Mediterranean is right here, and that's Portugal to the left right there. So Madrid is dead center, and the water temperature is about 22 degrees Celsius.
Oh, nice.
And this shows the watersheds. So there's a mountain chain at the edge of the purple. There's mountains all over the place in Spain, really rugged terrain. But at that vertical purple-blue interface, green-blue-green interface, there's a lot of mountains. Everything to the east runs towards the Mediterranean. Mm-hmm. So like they say, the Mediterranean watershed occupies about 1/3 of Spain. The rivers are short, with the exception of the Ebro. Their flow is irregular. So it's based on the precipitation of the time of year. That's a Mediterranean climate. Just like California, we have wet seasons and dry seasons.
Mm-hmm.
Okay, so there's a view from the flight radar. It shows pretty well the nice rugged terrain that encircle Valencia. So everything from the mountain peak, center of those mountains basically flows towards Valencia, towards the Med.
Okay, right.
And then you have this thing right here called the Rambla del Pollo is the name of that channel. It's highlighted here on the right in this lower part of the picture right here. It runs from the mountains up near the city of Chiva, and it looks like this in the middle of that city. It's just a big dry wash.
Wow. Okay.
Normally.
Is that like ground? Is that ground or is it?
That's dirt.
Yeah. Really? It's not even like a cemented channel. Okay.
Nope.
Interesting.
Pretty natural, and most of it's got trees growing in it in certain areas, and I saw a lot of pictures of it through the areas as I was exploring all the tributaries that run into it. It's not just one channel; it's got branches coming together, and like any river system, you keep on getting more and more water towards the end.
Yeah. I find that extraordinary. Actually, wouldn't you think that? Well, even under normal circumstances, that water running through that would sort of create like an erosion thing, and then would eventually work its way to the buildings. But obviously, it doesn't because it looks like they've probably been there for a while.
That's probably bedrock. It looks like when you look. Right. Let me try to zoom in right there. That looks like pretty rocky soil.
Yeah, it could be just rock. All right. Okay, gotcha.
I'm guessing, yeah.
It would have to be.
That's not concrete there. That looks like just natural rock.
So that's why they didn't have to concrete it. Okay, thank you.
Or really old concrete. I'm not sure. So
probably some previous town that they've built on top of.
The point is that thing runs right through all these towns. Here's the other picture to show. It shows you that you have 160 kilometers from there across the Mediterranean. And the reason that's important is when you have a spinning circulation center out here, and you'll see that shortly with the satellite, and the winds are out of the south, it's flowing across 100 miles of water, warm water. That's key to this. Okay, so that's the geography. Now I want to go big picture. So here is what happened. I'm going to widen that out as much as I can. How's that look? That's about as big as I can make it.
Yeah, that's good.
Okay.
I can make it a little bit bigger.
You can see here's Spain, dead center. You have Dublin, Ireland's right there, UK right above it. Okay. I'm going to just play this. So here's your fluid atmosphere, and you can see that spinning thing right there. That's a low pressure center. Then you can see the curve in the blue clouds. Those are high clouds. It shows you where the jet stream is.
Holy moly.
The jet stream will be going over the top of this right here. So what happens is that thing, that spinning area, parks around the 26th. I'm going to back that up again here. I wasn't commenting on it, but the nice thing is you can go really fast here, and you can see how this all just flows. Yep. So you can see the spin working its way south, its way south. It's now over Spain, and it is completely cut off from the jet stream, and the jet stream is way up here where the blue is.
Okay.
So it has no forces acting upon it until way towards the end here, early November. This blue area is another cold front comes and bumps that thing out of there. But it's been there. It's going to be there for like a week time frame. And right here, it gets ejected out by this other cold front coming through. So that's the big picture.
That's amazing, isn't it? I just love looking at it like that. It makes everything make sense.
It really, yeah. that picture is worth a million words.
Yeah. Like there's two opposing swirls going there, and it just kind of gets stuck.
The cutoff lows, we're going to talk about them pretty in depth here, how it happens and everything. But here's one more satellite picture for your visual. This is the last day and a half before this big set of storms hit that area.
Okay, so this is before the flood.
This is the day before up to the flood time. And you can see when the Valencia area has this blue coming up, you can see it coming down here. It's spinning. You got early morning on the 29th. It's down here and it spins up to the north and then it just dumps. When it's really dark blue, those are indicative of the cloud top heights. Minus 40 is like a gray just before the white. When you get into the blues, it's minus 50, darker blues minus 60. So that means the cloud tops are growing to the extent they keep cooling as they go up. So they're getting higher and higher. When you get to that dark blue, it's really, really cold and really, really high.
Okay. So
here's one more quick look. And right then was all that's happening the evening of Tuesday, the 29th.
So that
area is getting dumped on.
Okay. The jet's kind of almost acting like a bit of a fence, isn't it? It's just making it go. It can't go anywhere but round.
But that's a long ways away. We're talking UK. North of the UK is where the jet is. Okay. It's just sitting and spinning and meandering and lollygagging is what it's doing down there.
Got nowhere to go. Okay.
Okay, so that's the closer, more recent view. And then I want to show you something right here. So here's 3 pictures simultaneously. Radar upper left.
Okay.
The temperature at 500 millibars, which is 18,000 feet, which on Radiason data, every Radiason reports the 500 millibar temperature, along with 700. There's mandatory levels that are reported. This is one that's reported because it goes onto the weather charts. 500 is a really important chart, and it's indicated right here, 500 micropascals, hectopascals. This particular chart is a really good one when you select temperature at 500, because that purple dark blue area, that junction right there, shows where the jet stream is.
Yep. Okay.
And it shows you also that these white colors are like minus 30, and this is like minus 20 or 25, the purple. So it's showing a cold pool of air. This is the 29th at 00. This is just the day of the event, okay? So I'm going to show you several pictures of the day of the event. So you've got simultaneously radar, upper 500 millibar temperatures, and off to the upper right, you have the satellite. So I'm just going to look through them quickly, and you can see how this stuff moves. This is every 3 hours. So you can see them aligning perfectly concurrent with each other.
Okay.
And this is about the time that the downpour was happening. Because Spain time is the same as Greenwich Mean Time, which is the same as Zulu. So
okay.
They're on the same time frame. So this Zulu is the time of day.
Nice.
So what you have in the upper air then is a low pressure, cold, low pressure center just isolated over that place, over Spain and Portugal. And you have a ridge of high pressure pushing up this way. The jet stream is diving down over Greenland. Greenland is over here. So it's Greenland's right there. So you got a trough of low pressure, a ridge, and then a spinning, isolated, cold pool of air over Spain.
Okay.
So here he comes across. So here's a trough of low pressure over Iceland, extending down towards the UK. There's the UK. Here's Spain down here. So you can see what's happening here. That cold extension to the south, the jet stream finally just goes right across. It just isolates from it right about, let's see, this is the date of the 25th. That trough right there, that U-shaped area, separates from that on the 26th.
It's like it planted it there. That's weird.
And then it's just on its own now. So I think this plays out to the 30th. Yeah,
And we've got these opposite spinning motions going on.
High pressure here. So that's in the northern hemisphere clockwise, counterclockwise with the low pressure center.
Mm-hmm.
And because that low is sitting where it is, the winds around it are going towards the center. And with all the winds going towards the center, you have convergence. And you can't pile the air up, so it has to go somewhere. It can only go up. It can't go down to the surface of the earth.
Mm-hmm.
So you have rising air at that point. And then you throw in a south wind on that eastern side, the right-hand side of that low. Okay. The winds are out of the south. You can see these little barbs right here that are moving that way.
Mm-hmm.
Let me back it up a little bit and just watch the motion of those things. You can see where the winds are. So they're coming across the Mediterranean, and that low is over Madrid right there. But when it backs back towards the Atlantic to the west, now the winds are blowing across the Mediterranean, bringing warm, moist air.
Oh, okay. Yeah.
Towards Spain.
Just adding, yeah, because of the temperature of the ocean. What was that? 22 degrees, wasn't it?
Yes. So it's
Celsius,
warmer than the air. Yes.
Yes. So lots and lots of moisture being added all the
Correct.
time. That's being fed into it. Okay.
So here you can see the radar that goes with it. And you can see that spinning center moves around because you could see the swirling point. It's the center of that low. So this is like a 5-day period from the 25th all the way to the 29th, I think. You can see how by the motion of the rain that it's jumping all over the place. It's wandering. Mm-hmm. My point with showing you this was that the rain goes along with that low pressure center.
It's been fed all this water from the Mediterranean and just sort of stuck in one spot.
If the low is wandering back off of the coast, it's feeding through not much water. Whereas if it moves to the east and the low is right here, you get a 200-mile swath of water versus 100 miles.
Yeah, okay. Now I understand. Yep, got it.
Longer time over water means you pick up more.
Yeah, that's why you were showing us that stretch before. Okay.
This is a Valencia sky view of it. So this is a very similar thing. You can see that the showers wander around with the position to that low. And this is not as beautiful as Wendy's, but you can see Chiva is one of the cities that's named here. It gets a lot of rain, and I'll show you some numbers soon. But you can see that the wind...
Are you talking about this time of year? It normally gets a lot of rain and moisture?
Well, it depends if you have this cutoff low situation starting up. I mean, it's normally not like that. You normally have cold fronts coming from the west and just sweeping through. And a cold front is, hours of rain and then it goes away. This is different. That's been sitting there for days.
Yeah.
So that just shows another view of the radar with Valencia sky. And I don't know why I have this one. Oh, I think this was to show it was like an atmospheric river on the 28th near Valencia. Watch how there's a mountain chain that runs right up through here. Look how it just keeps on the same line.
Yeah, okay. Yep.
And right through Chiva. And the reason why is because you have moisture coming off that flat sea level surface, but the terrain makes the big difference. If you push it up that slope, it cools. And if it cools, it condenses. When the temperature becomes equal to the dew point, you now have a cloud. And then it oversaturates and it drops rain if it keeps lifting. Mm-hmm. So the terrain is really big in all of this. The Mediterranean is really big in all this.
Yep.
So now the one I want to show most right here is that rain right there that we just saw was through this area. And look at the terrain right there.
Very mountainous. By the looks
it was
of it.
Coming from the south or from the southeast. And that line of mountains right there was the reason for the lift, partially,
Because of the
orographic lift.
mountains? Yeah.
And here you have the town of Chiva, and then you have the town of Buñol. They're right at the foot of the mountains, and then you have this dry bed.
Yeah, the dry
meant
bed.
to channel the water to the city. Okay, so this shows the orientation of the rain, same orientation. And look at the highest amounts are from Chiva to the northwest, and just a big elongated area that aligns with all those mountains perfectly.
Which makes sense. Yeah.
Totally makes sense. It's being lifted.
Yeah,
So,
I mean, it's got nowhere to go. It can't sink into the ground. And
especially if it's a really
so.
dry climate where the ground is really hard a lot of the time.
Yeah,
you
so
don't
therefore,
have-
the rain's going to, or the water's just going to go rushing over the top instead of soaking in.
Like a forest is full of leaves and you can't get water flow moving, whereas on a hard baked ground. So here's some numbers. In Chiva, 461 millimeters were recorded, the highest figure since 1996. 520 were recorded. This is not a one-time event.
No, it's not a 1 in 1,000 million year event, as they were saying, or whatever.
It is not.
It just gets bigger each time. No.
And
2018 was also a very big year for rain in Spain.
I know Black Pearl in our Climate Viewer chat group, he did a whole bunch of stuff on this stuff. So if anybody wants to go and dig into stuff, he's got a lot of links in our Climate Viewer chat. So if you want to dig into this anymore, but you could see
he's been doing some great work.
He's been busy, yeah. This names a whole bunch of places here, and they're kind of grayed out. It's not active because it's a screenshot, but 267, 300, 402, 461. And you can see this is showing time. This is all Tuesday. So this is 9 in the morning, 12. At about 3 p.m. it started, at least in Chiva. So Chiva's farther inland. All the other ones started a bit earlier, but then Chiva went nuts. And the reason why is because the mountains really get steeper up near Chiva. They get really high. So you have more lift. And then on top of that, what else happens at 3 to 6 in the afternoon? That's the hottest part of the day, typically. So you have sun hitting the ground wherever there's gaps through the clouds, heating heating the ground and causing convection. So you had not only the orographic lift, but the convection happening during the warmest part of the day. Okay, so the next one, I'm just showing you some observations at different places. These are the official observations, but just focusing on the precipitation. This is Valencia, 6 a.m. through the end of the day, rain and thunderstorms all around. Here we have the official observations. That's the METAR line right there. So you can see the gust to 39, gust to 40, gust to 37, gust to 33, super windy, humid, only 70 degrees Fahrenheit, which is converted to 21. And then you get the water temperature of 22. I converted it for you right there.
Thank you.
I'm learning, Stella. It's hard. It's hard to drill through, but
this one has been particularly hard because of the fact that a lot of these sites were in Spanish, and we've got to translate. Sometimes it's easy, sometimes it's not.
Yes.
So it has been quite an intense research.
Okay, next one. This is the city of Torrent, which is right next to that canal, that dry canal. During the day, see, 6 p.m. is about the time that it really happened. So it was muggy already. 66 degrees and muggy doesn't seem to be a fit to me. I can't imagine that. But the winds up to 49.5 miles per hour. That's gusting. But you could see in the morning they were 10 and increasing throughout the day up to the 25 to 30 range with gusts to the 50 range. So needless to say, we have a lot of proof that there was some really nasty weather there when you dig down to the level of the observations. Flight radar, need to rule that out. So this was the view. I actually had, at first, I had all these filters on, 12 to 20,000 feet, military, government, NASA, 30 drones, and US Air Force. And then I said, because when you have that happen, only the ones that meet the criteria show up, and they're grayed out because nobody meets the criteria I'm looking for. They're just commercial flights. So I took that off, and then I get to see all the data for each flight. So I'm looking for from the 28th, like 0Z, midnight on the 28th, I looked at 2 days of data, watching each of these flights to see if there was anything that looked like it was doing circles over the mountain. There was no event. There was no
so you
aircraft.
looked at a couple of days before the event. You were studying quite hard. Okay.
Yes.
So you were looking for military as well as drones and all that sort of thing. You covered everything.
When I came to this view, yes. When I came to focus on these mountains right here, that's where they would have done it.
Yep.
It would have been over those mountains if they were wanting the rain. My look first was 5 days at 300 speed. This is at 20 speed. So I looked at just military aircraft first. I looked at 5 days of data at 300 times speed, and I didn't see anything. Then I localized it and looked at the last day and a half.
Yeah, because I mean, they wouldn't be doing it. They wouldn't be doing it much before a day and a half before an event, would they? Because it's too far away, sort of in time. Yeah.
But I looked 5 days first, which was pretty stupid. I wasted 3 hours.
Well, maybe it's put somebody's mind to rest, so let's hope so. It was worth it in the end. We'll never know.
This shows the temperatures I was looking for that -5 to -10 degree range, and I have Valencia here. So you're looking for the -5 to -10 for cloud seeders, and this shows that it was -8 at 14,000 feet.
Okay. So that's sort of prime.
That's why I looked at that 12 to 20,000 foot range. So that's that one.
So that would have been a prime spot to do it if someone was going to do it, and there was nothing there. Is that what you're saying? Okay.
Right.
We just stretch that window out.
This is the day. This is the day later, the 29th, the day of the event, and -6 at 14,000. So you would have had to go 14,000 and up another couple thousand feet. You have a 14 to 16,000 foot range right there where you could have been. But nobody in their right mind would have been seeing what was happening. So that's kind of
that's what I was going to say. It's sort of like, I mean, these cloud seeders aren't just fools that just go, oh, might just go up now. I mean, they know what's coming. They're reading the weather and everything, and they would like imagine the most nefarious black project, right? They would look at that and go, we don't have to do a thing. I mean, they would know that there's some heavy weather coming, and I guess, know the terrain probably a lot better than we could know in a few hours.
Right.
And they'd know pretty much exactly what was going to happen if they're worth anything.
You have a meteorologist. You have either a meteorologist on staff on call, somebody that you call, or somebody in your company is that person. So you just don't cloud seed at any time. It has to be appropriate times. There's a video that I shared in the Climate Viewer group that has that aircraft 522 JP Beach King Air, but it's a sleek, waspy looking plane, and it's got the flares on the back of the wings. And it's very specific. The geoengineers were talking us through it. They gave their whole process away. The temperature range, the whole works, which clouds to use when, or which flares to use when, because there's flares on the back of the wings and there's flares on the belly that shoot down into the clouds if you don't want to be in the clouds for maybe icing reasons.
Mm-hmm.
if the aircraft, I mean, I'm getting into something that didn't happen here.
Yeah.
But
that's how they do it. Yeah.
That's how they do it. Yeah. So I should have given this information a little bit earlier. This shows how a cutoff low forms. I kind of showed it, but this is a diagram inside of a paper that will be included for anybody that wants to dig into this. So A, B, C, D, E, F. So you got a ridge of high pressure, a trough, a ridge. We saw the trough that was over Greenland. You go to B, it starts to steepen, that ridge steepens, and then the low deepens, and you start to get a little circulation center, but it gets so steep that the jet stream eventually just cuts across and does a shortcut. And that leaves that low down there by itself. And that ridge of high pressure was showing that I pointed out on the actual photo of the jet stream. That ridge going to the north, the low was sitting over Spain, and then it just sits and spins and meanders.
Yeah, just goes round and round.
So here's another good paper. I've included this as well. This shows some of that water flow that was happening. I'm not sure what town this was in, but in Spain, they have the meteorological agency there is called AMET, and they have a Spanish acronym of DANA for the cutoff lows.
Yeah, the actual translation is like, yeah, I think I might leave that one.
It's also known as a cold drop. Anyway, you can read this if you want, but it's just different terminology. They have it in Spain. This is a really excellent PDF for anybody that wants to dig into it. I'm not going to go into all of it here. I'll just point out a couple things. I'll give you the links for that. Yeah.
Okay.
This is the important part. How do cutoff lows progress? I'm just going to read this. I'm going to paraphrase it. Gives the idea they're not very frequent, yet this is not so. Studies made to count the number of cutoff lows. Here's a database with a window that covers Western Europe and Eastern Atlantic. Talk in terms of some 15 a year on average. These being more prevalent in spring and summer. Two zones can be marked out as those more commonly beset by cutoff lows. The southeast of the Iberian Peninsula, that's Spain, and the Mediterranean zone to the southeast of the Iberian Peninsula. That's exactly the area we're talking right there. The point to all this is there's a huge variation year over year. You might have 10 or you might have 20 of these. It's not uncommon. This was a lining of a bunch of stuff that wasn't so good. So it was worse than normal.
I mean, it has happened through the years. I've got a little bit of a list here of in 1957 there was a pretty high rainfall. 30 years later there was another very high rainfall in Valencia area, 817 millimeters. 1987.
817?
Yep, in Valencia. So that was 1987, yeah.
So you're talking 81 centimeters, which would be about 40 inches, 30, 2.54. 2.54 centimeters per inch.
Yeah. Anyway, the point being that it's happened through history number of times.
So this was just worse than normal. It parked for a long time, and we have to talk about stability now because I'm going to show you the radius-on data that went along with this event. So stability. There's 4 different ways that you can look at it. You got absolutely stable, you got absolutely unstable, you have neutral stability, and you have conditional instability. So they use a cup and a ball inside of it as your way to understand it. So initial starting position, ball's in the bottom, and it comes back, returns the starting position. Yep. This is what you have on the west coast where you have cold water under a high pressure ridge with an inversion. This is San Francisco. Absolute instability. If you put any force, it continues to roll. Absolutely unstable. It keeps going no matter what. Neutral stability, put a force on it, it stops, no further movement. And here's the conditional one. If you give it a nudge, a weak force, it returns to the normal position, original position. If you put a strong force, it continues moving.
Okay.
So why that matters is a situation right here where we have mountains. So you have a mountain, your wind flows from the west. With a stable condition, it goes up over and then comes back down. With neutral, it goes over and just continues to move at the same height without going back down. And unstable, as soon as you hit the mountain, now it's very unstable and you get vertical currents.
That's an excellent graph. That really shows it. Yeah.
It is very good, yeah. So it doesn't have to be mountains. It can be a frontal lifting, a cold front or a warm front causes lifting. It can be convergence at the center of a low where all that air is spiraling towards the center. It's converging on the same spot. And it can be convection, like they show up on the top view right here, just from the sun hitting the earth.
Yeah, moisture.
So you have all these methods of getting that initial lift. So in this day, here's Valencia, here's the sounding site.
Okay, what date is this? 29th, okay.
This is the 29th. This is at noon on the 29th, just before it really got bad up there. That got really bad around 5 or 6 p.m. So when you use windy, you have this active cursor. I can actually go to that here shortly and show you this in action, but you have the temperature line, which is red. You have the moisture line, which is blue. And then you have some numbers down below. T-con is the temperature convection 25. It did not hit that on that day. It was probably 22. You had 22-degree ocean water as well. So it was only 70, which was 21 when we looked at the Valencia observations. But you have a convective condensation level of 3,035 feet, and you have a lifting condensation level of 1,660 feet.
Okay, can you just very briefly explain what that means?
So if you lift the air to 1,660 feet above the level of this location where this place was, that green line right there shows the temperature of the air as it rises above that point. When it condenses right there at 1,660 feet. And then you have the environmental temperature of the air, which is what the radiosonde actually measured. But now you're talking about forcing a parcel of air upwards, up a slope, and that's the path of temperature that it's going to follow. And that green line is to the right of the temperature, which says it's warmer than the surrounding air. If it's warmer, it's going to continue to rise. If it was to the left of the red line, it would be stable and it would just be flat clouds. You wouldn't have the vertical development that we were seeing here.
Right, like the rain clouds, basically.
The heavy cells that were happening. And
full of moisture.
This shows that right where it intersects the red line is where it becomes neutral again. And it crosses to the left and it becomes stable. So that's 200 millibars right there is 40,000 feet, 300 is 30,000. So it was about 33,000 foot tops to those where the temperature was really cold. And we saw that in the satellite with those dark blue and light blue areas along this area where these rain showers were over that terrain.
Yeah.
So this was in the morning, that satellite picture right there. But that was later in the day, it moved to the north and affected that area.
Heading up to the mountain areas and all that lift going on.
That leaves one thing to talk about, ice cat. But Jim's going to go into this in detail.
Yes.
I think I've covered everything else here.
So let's just do a quick recap before we get into ice cat.
Okay.
So basically what we're seeing so far is you've gone over the geographic sort of situation and how much that plays into the weather movements and moisture movement. And you've looked at the terrain, or the movement of the water over terrain, being over fairly dry, hard terrain, rushing down towards towns. We've looked at the possibility of cloud seeding, which, from what you've seen in a very detailed search, doesn't seem to be coming into play from what the information that we are presented with. And also just looking at the whole situation. I mean, it doesn't make sense, because it doesn't make sense to do that, because this is going to happen anyway. Anyone who knows what they were looking at in the build up to this event, I mean, that's how they know to warn people, isn't it?
Yes.
That's another bucket of fish, though, like the whole how much warning they got and what happened afterwards. That's not what we're looking at. We're just looking at the meteorological situation. So if somebody wants to find out about all the other stuff, it's another show, another bunch of people. It's not us. So ISCAT, where does this fit in?
Before we go on a little bit more here, when this guy, this is a local guy right here. When you look at this video, this Spanish guy, he's talking about it because he lives here. I strongly suggest you watch this video. He does not think the government did a good job. He does not think that the response was good. The warning was not right. It took a long time for that rain to happen and then travel all the way down there. I mean, the coast is there. You've got 4 or 5 towns right there. That's probably 5 miles there. It's probably 20 or 30 or 40 miles inland to that point. So he's not happy with what the response was or the warning.
This is the thing, isn't it? It's sort of like, I mean, I totally get people sort of being suspicious about everything, because there's so much nefarious crap that goes on, but maybe people are sort of looking in slightly the wrong spot. Like, I don't really think we should be looking so much at what's being, to quote the rhetoric that's around, steered or created as far as weather goes. But what needs to be looked at is, what he's saying is like they should know that this sort of thing is coming. There needs to be a better warning system. There needs to be a better response afterwards as well. So that could be something that people might want to put their energies into a little bit more, as holding people accountable for those things, perhaps.
That makes sense.
Yeah, and it seems to be happening everywhere. So, I mean, it even happened in Lismore here in our floods in 2022. Same story. Not much warning and a terrible response.
Yep.
And it was the people. It was the people that got things together and saved a lot of lives. It was just dudes in tinnies, which is just little motorboat things, going around from roof to roof trying to save people. And we didn't have the government to thank at all. There was private helicopters, all the same thing, same story. Yep. So this is where I think people maybe would be better putting their energies into the authorities in that sense and holding people accountable. But I mean, I say that with a little bit of jest, because nobody is ever held accountable. Sorry, that's my clear-pilled version. But it is the way it is. Anyway, I just wanted to add that, because I think people are sort of wasting their energies in maybe the wrong places in some instances. And I'm not saying that's always the case. There's definitely cloud seeding projects that happen, but I suspect not maybe in the same places that people are looking. Or, I mean, people are giving them too much credit, I think, for having these powerful weapons that can somehow create hurricanes, what have you. I mean, if that's the case, we're all screwed, I don't think they'd go about it that way so gradually. I mean, why would they? It doesn't make sense. It just doesn't make sense. There's better ways of controlling a population. Anyway, carry on.
Let's go to what we were going to talk about, which was ISCAT. Just a little bit here, and I want to show you the power consumption. Well, first of all, just very briefly, because as we said, Jim is going to be going into this. Just, can you tell us exactly what an ISCAT is? Well, you already did. It's an ionospheric heater, right, similar to HARP, and it looks like a big radio telescope dish, like we're all used to sort of seeing. And it sends, I did not prepare for showing people this because Jim's doing that part, but I just want to briefly show that we have the records of minute by minute power consumption and it shows the peaks, and it shows if it was UHF, VHF, or heating mode. And of all these days that I had right here, I took screenshots of all those days from the 17th, 16th down to the 30th, and there was only one day that had heating mode, and it was for 8 minutes.
Okay, what was that day? 17th, was it?
Actually 10/16. They do the month and year back, or the month and date backwards. So 10/16.
That's right. It's all wrong way around. Okay.
8 minutes.
So what? Yeah. All right. Well, we'll go into that with Jim in more detail in the next show. But interesting observation.
So
8 minutes doesn't sound like very long.
We have access to the records. We can see when iSCAT is on and in what mode. That's kind of the only thing I can really say here. I'm not prepared to tell you more, but if I look at any of these graphs, any of these right here, it shows when it's on, when it's off, when it's low power. I mean, this is the power over here, and it tells you last hour's power and the present power and maximum last month and the accumulated for the year, I assume. So it gives lots and lots of data, and we have access to this.
That's the whole point. That's why we're showing this, is because people can access this information. So whether they're going to access it and understand it is another point. But the main point being the information is accessible. And I believe even if you don't want to believe that information, you can actually cross-reference it with other places that show data.
Yes, you have access to all this information. And here's the status of the project, what it said last I saw. The antenna units have been installed at 3 iSCAT 3D sites. Stage 1 was 3 sites. They do a transmitter upgrade to higher wattage later. Stage 3 is adding a 4th site and then a 5th site. First stage is being constructed, will be fully implemented when stage 4 has been complete. I watched the data, and they're adding, and the power consumption's going up and up in periodic periods. So this is on the iSCAT site. So anybody can go and find it.
Yeah, that's being the main point. It's available publicly, this information. So again, whether you understand it or not, it is there. Right. And if you want to go even deeper and say, oh no, they're just creating that, it's not real information, it's like, okay, we'll prove it for a start, but you can probably cross-reference it with some other data if you really want to. Correct. I mean, you'd be able to look at, temperatures in certain areas, meteorological temperatures, etc. If you really want to know, you can do it. So that's the point. It's not hidden. They can't hide it. It's impossible.
They can't.
Because it will be cross-referenced with some other system or data set from some.
And you can hear it.
Area.
If you have, like Jim talks about it, you can hear when it's on. It makes a particular noise. And if you listen for that on apps that you can get for the computer, you know when it's on because it makes a noise.
Yes, and there's plenty of people who, just for a hobby, watch this stuff. I mean, try pulling one over their eyes. There's going to be ham radio people and all sorts of people that are up on this stuff. You've just got to look in the right places to get the information. I mean, it's not going to be in the news, is it? But there are ways to access this information. If you really, really want to, and you want to know the truth, you can do it.
You can't just scream "HAARP is on." You have to prove it. Show me the data.
Yep.
And in this case, what's the question, Stella?
So tell us, Jeff, was this weather or not?
It was not HAARP. It was not the ionospheric heater up in Norway, which is right there. There's Tromsø, just north of Spain. It was not cloud seeding. This looks to be natural weather.
From what the data is presented that we can see, yes. And
Satellite.
Look at it. I mean, just look at it. That's, as you say, a picture says 1,000 words, or 1,000 data sets, really. You've just got to look at it to put a little bit of logic into what's, I mean, anyone who's sat there and watched a river or a stream and the way it curls around rocks and different obstacles and things will understand what the sky's doing. It's not rocket science, really, in one sense.
Agreed.
It's sort of, it is, but it's not. Like, look at it. Look at that. It's going to sit there, and if it's going to dump a lot of water. And when it rushes down the mountains and down the hard surface of the, down, I can't think of the word, but
Rambler.
yeah, corridors. Yeah.
Rambler.
It's going to gain speed as it's coming as well. That's another thing, is sort of like the force. I mean, immense. We saw the pictures of water rushing through little thin laneways and alleyways and things. I mean, there's buildings and stuff in the way too. This is the other thing, is the planning of building towns, etc. I mean, is it wise to build a town at the foothill, the foot of hills or mountains? It's like, well, is it wise to build next to a volcano? Probably not. Well, there's a chance. I mean, you just got to know your chances, your risks.
You can see right here, Stella, you want me just to play a little bit of this to show?
If you think it's going to enrich our knowledge, sure.
I mean, it shows early on how it presented itself. It started,
Yeah, this is the sort of thing.
This is all over the place. I mean...
Yeah, I mean, the point being that it's going to go rushing down. If it can't just, if there's obstacles in the way, it has to go round the obstacles. Therefore, the force is going to increase as it makes its way. And urban sprawl means that there's going to be a lot of people affected and a lot of property lost. So, okay, let's do a wrap up. So, can we just go over this again briefly? Can you do a little wrap up for us, Jeff? Was it weather or not?
This was not cloud seeding. This was not HARP. This was not ionospheric heaters in Tromsø. This was a low pressure center that cut off from the jet stream and sat and spun and lollygagged and dumped rain, grabbing moisture from the Mediterranean, which was warm, and pushing it up topographically up the mountains of Spain. It's a very mountainous place, and the air mass was unstable, and all it took was a little bit of a push up a mountain slope to get it going, and then the sun, the hottest part of the day, aligned with that as well. So you had convection, you had convergence, you had orographic lift, 3 methods. The only thing missing was the front. You had 3 ways to lift and cool the air, and it dumped. It took the Mediterranean water, moist air off of the Mediterranean, and dumped into a gully, which was designed to bring the water towards the city, and it flooded the cities.
Yeah, I think you could pretty easily sum it up with, it was a Spanish recipe for disaster.
Unfortunately, yes.
Okay, well, again, thank you for bringing that level-headed data knowledge to our attention. It does make sense once you understand what's behind it all. And it's been an immense amount of work, because it's been hours and hours of observations for Jeff particularly. I've certainly done some of my work as well to know, just sort of satisfy myself about what is and what isn't. Oh, we should address the dam thing too. There was some information getting around about, dam removals being very prominent in the last couple of years, which is a fact, actually, all through Europe. And actually Spain does lead the way in the sense of so many dams were removed. However, it appears from what I looked at anyway, it appears that the dams that, generally the dams and weirs as well, because they're counted in the weirs, are removed generally because A, they're no longer working, B, they're in bad, they need, a lot of money and maintenance put into them, and they're sort of not really worth doing. C, they are definitely doing the green agenda where they're trying to improve the environment. And I've got to say, I mean, I'm not really against that, because, dams weren't really meant to happen in the first place. So I hate to agree with them, but some things they are doing do make sense. But no alignment. But, the fish are pretty happy about some of these situations. Some of the natural flowing salmon have sort of increased in numbers since some of these dams have been taken away. It just appears that it's just another, and I'm not saying that, there's nothing nefarious going on, because there is, but I don't know about with the dams. Well, not in this situation, at least, it seems. It was like 4 major dams that were being taken away or something, that everyone's saying, it's because of the dams being removed. It actually really didn't have a lot to do with it at all, or anything, actually, from what I looked up. But, I can only go on the information that's presented, but I've probably looked at it more in depth than some people that are making claims. So I'm happy with that. But again, I think we probably need to look at the government responses, etc., and leave a lot to be desired, the warnings and the responses. And unfortunately, usually what comes from that is tighter restrictions and more surveillance and things, because they see that as their solution. So we also have to be wary of that, kicking up a big stink and they go, oh, well, then here's a solution, I mean, what do you do? I think what do you do is you become more educated and keep an eye on things yourself a little bit more, perhaps, and stop relying on hearsay for a start and social media unsubstantiated claims. Learn to read the data, I think, is probably the best solution. Education usually is. And I think on that note, we could probably wrap this one up. Thank you, Jeff.
Well said.
Efforts.
Very welcome.
Well, if anybody's still here, thanks for hanging around, and really hope that we've put maybe a mind or two at rest, perhaps, and maybe educated a couple of people or intrigued some curiosity to go and learn a little bit more, maybe explained a couple of things. I've learned 1 or 2 things myself, as I always do. It's the whole point of this. You're just along for the ride. I'm learning. All right. Well, thank you very much, and God bless everyone. Let's hope that these people are finding their way through these awful events. On that note, take care, everyone.
Bye.
That makes sense. Now, can I just ask, because I didn't really hear, what's that just underneath Spain? That's Brazil, isn't it?
Oh, that's Africa.
Africa. Told you I wasn't there that day at school. Okay, I was going to say Africa originally. I thought, no, you idiot, it's Brazil, but I was actually right.